Welcome to another episode on 2023 number challenges. Here we're dealing with what is called a square plus plus number. Of course, I coined the term myself. It's not standard terminology in mathematics. Here we're looking for a number that starts with, of course, 2023 and is a perfect square. The whole integer in decimal digits is going to be a perfect square. And in the meantime, it can be two parts. The first part is a square, and the second part is b square. All right. So for example, number 16 is a perfect square. That's 4 square. Number 9 is 3 square. And 169, if you put them together, we call this number a square plus plus number because the whole thing is 13 square. So let's go back to the original question. We're looking for a square plus plus number that starts with digit 2023. All right. So the first thing you want to do is figure out the first part, right? What integer square is going to be 2023? How do you search for that? All right. So you probably want to start with the square root of 2023, or maybe 10 of that, times 10. Any other number is going to be a multiple of that, right? Like just shift digits around. So you're looking around 449 or 4497, or looking for around 14223, things like that, right? So let's do that. I was able to calculate, and okay, looks like there are a few choices for us, right? So let's pick this one. I like this one better, right? So as a matter of fact, you can pick any other ones. Follow the same procedure, you're going to be able to find another set of numbers, okay? So this number I pick for a, okay? So a squared, in other words, the number we're working with is going to start with this quantity here. Let's go back to the original question. That is, we fixed a here. We're looking for b and c so that the whole thing is a perfect square. All right, let's do that. Let's do some mathematics here. And we're going to turn this into an equation, right? So what is the meaning of that? So let's assume b squared has k digits for some integer k here, right? And so that this whole integer can be written in terms of k, right? And in terms of b. All right, let's rewrite this number as c squared equal this leading digits times 10 to the k power plus b squared. And what is b squared? B squared has exactly k digits, right? So that is b squared is going to be, in terms of the value, it's going to be in between this, range, right? So, and then of course, c squared is a perfect square, right? So let's work with algebra a little bit, okay? So what we can say, maybe we can shift around, right? And so b is in this range, and let's take a square root of it, and this is rewrite the original equation here. So this entity is a product of two numbers here, right? So notice that two integer here, the difference is 2b, that is, they must be either even or odd at the same time. The parity are the same for these two terms. And of course, here we know that this is a bunch of zeros, so it must be an even number, that is, both terms must be an even number, right? That's what we know from this simple equation here, right? Just some simple analysis. So we assume they are even number with, m and n, where m is bigger, right? Because this is c plus b, right? If that is the case, then c and b can be expressed in terms of m and n, right? C is m plus n, b is m minus n, okay? So earlier we mentioned that in order to avoid like trivial solution, we assume the second number, b, is not a multiple of 10, all right? Because once you find a solution, you can always append in a bunch of zeros to make a new solution based on that. So we're gonna ignore those, trivial solutions with ending zeros. We assume b is not multiple of 10, okay? So that's what we got so far. Now let's work on some algebra in terms of b here, because here we take a square root of this, yeah, and this is so b. Of course, we know that earlier when m minus n, what is m and n? You can express n in terms of m, right? So let's do that. Okay, so here you notice that b in terms of m has this relation here, yeah, and we know that b must be in this range. Okay, so notice that this function here is actually strictly increasing when m getting bigger and bigger, right? So m is integer, positive integer here. So b is in terms of m is strictly increasing function, and if we want to limit the range of b in this lower bound and upper bound, right? So we have to figure out the corresponding m. What is the range of m? Okay, just need to find out the equation for the two endpoints, right? So we call it here upper bound u, lower bound L, right? When you solve the equation, m minus t over m equal u or L in order to find out what is the range of m, what is the integer m we need, right? That's the whole point. We try to work out this algebra here, right? So notice that we're looking for m u for the upper bound, m L for the lower bound. Okay, this is based on the fact that this function in this range is strictly increasing. Okay, so yeah, it's just turn this equation to a quadratic, right? You multiply m on both sides. Okay, so what we get is a quadratic equation here. How do you solve the quadratic equation? Now we use standard completing the square technique, right? So this is going to be m minus u over 2 squared, and then you have some extra term, you can add it here. U squared over 4 is extra term from the completing the square. Right, m of course is positive integer here, so we can solve the equation. We take only one root for the integer part of it. Okay, what is the t and u? T and u are the constant that in terms of k, right? So once we fix k, we know what is t and u. U is the upper bound value here. We just plug in here. And all this is because we know that the b, the second integer part, has exactly k digit. From that inequality, we try to figure out what is m value we should take. Yeah. So notice that here you can have common factor here. This is common factor. You take it out from the square root. It's become 10 to k over 2 and divide by 2. Yeah. And then so this take it out from the square root. And inside it, you're going to leave with a squared and plus 1. All right, that's good. What is a? A is the number that we have chosen earlier, right? So this, you can further take out the common factor here, yeah? Okay, so that's going to be 1 plus this square root term, 1 plus, yes. Okay, all right, that's good. That's for the upper bound, right? So this m is for the maximum value of it, yeah? This is what is, we call it mu underscore u, right? M subscript is mu. Now, similarly, you can solve the equation for the other side, which is lower bound, right? And lower bound, we can just follow the same steps, and the solution is going to be replace this with L, right? In this equation here, this will be solution. But for the L, lower bound, which is 10 raised to k minus 1 over 2 here, right? T is the same, L is different, right? So, all right, this is a typo here. We change it to L. Okay, so and you can do a similar algebra here. Just plug in what is the value for lower bound L, yeah, and for the constant T. Okay, let's just plug in the values here. Okay, so let's let me see. And we also have the common factor here, that is 4 and 10 to the k's power, right? And then you want to take it out to the outside of square root, yeah, it becomes 10 and k over 2, right? Same as before. So let's do that. Let's take it out. And the only difference is that here we have some extra term here, k minus 1, right? So that's would be extra term here. It's no longer 1. Earlier is 1 for the upper bound, but for the lower bound is not. Is kind of 1/10, 10 negative 1s per 1/10. Okay. So let's do that. Let's combine the common factor here, right? And take this out, yeah, just same as before. What we have is 10k over 2 power divided by 2, and then in the square root we have a squared plus no longer 1 is actually 1/10, right? Yes, that's good. So, and you can further take out the common factor here, right? This common factor on both terms, and the first term becomes 1 over square root of 10, yeah. And the second part is going to be a square root of 1 over 10, yeah, okay. A squared plus 1 over 10, all right. So that's what do we have, the lower bound and upper bound for the m in terms of k, okay. So we got this range here, okay. So that's the algebra that we work out, okay. It's kind of tedious, but we know the upper bound and we know the lower bound, right? So let's continue with the process. So earlier we know that this is what we got, and from the math earlier we showed the steps. We got this, m must be in this range, okay? So let's do some math here. Multiply 2 and then maybe divide this, and this is a term that is will be constant once a is given. We know a is 14225, right? So we can say m in this range, right? Get rid of 2 here, fraction, multiply 2 on both sides, and then further change it so that you divide it by 10 raised to k minus 2's power to become 10 negative k, right? And what is x1? X1 is this constant here, and x2 is the right hand side, right? So x1, if you calculate it, x2, they're really close. They're off by almost 1, you know. So because think about it, this is a squared, right? A squared is a is about 14225. So not too far away from 14225, okay? So this number is sandwiched between these two numerical values here, right? So let's try to find out what is m, right? So remember, m is from this equation here, right? So m has to be a factor of this, right? So what is m? Okay, so we know that m must be sandwiched in here, and it may be easier to work with logarithm, okay? So let's take a logarithm on both sides, okay? And this k is the number of digits, m is another integer, so we need to deal with two unknowns here, right? So let's do some further analysis, right? Let's just multiply 2 on both sides, yeah? And then k, this is the integer, this is 2 logarithm, yeah? And then, we can just rewrite this, right? Yeah. So what is this? Let's figure out what is this quantity here, right? So k is the integer, k plus something is the integer. What is this quantity here? This quantity turns out, because x1 and x2 are very close, so this quantity is going to be very small, okay? So let's do that. Let's do some analysis here. This quantity is actually 0, 0, 0, 40, 10 to the fifth, range. So which means I'm looking for an integer so that this quantity here is going to be sandwiched by some integer that we don't know. But the fraction part is very tiny, right? The fraction part has to be smaller than this, okay? So so let's rephrase what we have so far. So we're looking for this delta value and this epsilon value here. So we're looking for m so that, this quantity in the middle is going to be in this range here, right? So in other words, we're going to take this quantity as epsilon here, right? What is epsilon? Epsilon is some value 7.7, approximately. So we're looking for integer m with this property here, right? So we take the fraction of that. The fraction has to be smaller than this delta, and delta is about 10 to the -5. Okay, so let's work it out. What is m here? We know that m must be a factor of this quantity here. So earlier we know that m and n cannot be both like a multiple of tens because we're looking for non-trivial solution where the b is not a multiple of 10, c is neither. Okay, cannot have an ending 0 here. So natural choice, m is maybe 5 some power, or there's a factor here, it's 569 here. This is 569 times 25. Okay, so our algorithm is going to be, let's say, assume m equal to this for some integer we don't know, and we try to calculate this quantity here. And if this would be fraction part, if the fraction part is smaller than delta, we stop, and then we try to figure out what is m, and what is t, what is n. From m we know what is n, what is k, right? So let's do that in a Python program. We have to resort a computer to do this because we're dealing with big numbers here. Okay, so this is just set up, and this is simple logic, to try to figure out the fraction of this quantity here, yeah, and this quantity, and then once we know m, once we know k, we know m, we know n, and from there we know c and b. Okay, it turns out that the algorithm works. We found a number, this is a t, and this is a k, and this is a c square is indeed start with 2023 50625, and the other part is also a square. The latter part identical to b squared. Okay, since match up very well. Again, this is just one solution. There are multiple solutions, right? Because t could be even bigger. And for the other choice of like for this choice, I have less luck. And the number is too big to be printed out by Python. Okay, run into some limit by the Python library. Okay, but anyway, that's the number, and I posted in the video description. Check it out and verify yourself. Of course, you can find other solutions, and please share your solution in the comments. All right. Hope you follow the steps. Please like, share, and subscribe to the channel.